Section G kind of ties some things together, but it uses the graphs to do it, so it can be a little ambiguous and a little tricky. We just have two examples, but let's remember, first of all, the sign of f prime tells things increasing and decreasing. The zero are stationary points, and they tell us our max and the mins. F double prime tells the shape or the curvature, concavity. Any of those words are important to know. And the zeros of F double prime tell us the inflection points, as long as the second derivative also changes sign. So we use our sign charts to determine everything. When we put on the sign charts, we put the zeros, and then we test out whether intervals are positive or negative. Okay, so I think one thing that's important is when we look at a graph, what can we learn? If we identify everything, you're going to get points for that, even if your graph's kind of iffy. All right, so when I look at this graph, the first thing that's very important, y equals f of x. Straight up, that just means when I plug in y or x, I get my y value. I'm getting f of x. And when we draw our f of x graph, this graph is going to represent f prime of x. That means when you plug x in, my y value is going to be the f prime. All right, so looking at the f of x graph, we have to find out features that we would know about f prime. So think about what we were just talking about. I'm going to make a little bit of room here. The first thing you always want to decide, where does f prime equal 0? Because if my coordinate point here is made up where my y value is f prime, where f prime of x equals 0 on the f prime graph, that's my x intercept. All right, so where do I see 0 slopes on this particular graph? I see a 0 slope here and here. So letters A and C are going to be my x-intercepts. I also need to decide, where does my derivative, where is it less than 0? When I look at this graph, it's decreasing and the rest of it's increasing. All right, so, and notice how A is where x is 0. So it's less than 0 where x is less than 0. Now, this is what's important, because this is my y value, where f prime has a negative slope, where f is decreasing. This corresponds to below the x-axis. A decreasing on f, because f prime turns into the y value on this graph. That means all of f prime of x is going to be below the x-axis for less than 0. Then where is it greater than 0? That's going to correspond to above the x-axis. Notice it's increasing, increasing. This whole thing is increasing after A, which is where x is 0. All right, so let's put on our 0 slopes occur at A and C. So A, and typically what they're going to do is have you draw it on top of this graph, but it gets a little confusing to do both. So I'm doing two separate graphs. So you'd come straight up, 0 slopes on F are the x-intercepts on F prime. This says everything before 0 is below the x-axis. Everything after 0 is above the x-axis. So I'm going to go above, but I've got to go down and pick this up and come up like this. All right. Now, the other thing to maybe think about, see how letter C, that's a stationary inflection. That means both this point, F prime equals 0, F double prime equals 0. Okay. All right. Now, let's do F double prime. We're going to do the same thing. Now, where is F double prime equal to 0? That's what we look for on F. Where does it change curvature? Where does it change from concave up to concave down? All right. From here to here, it's concave up. And from here to here, it's concave up. And there's this little piece that's concave down. I kind of over accentuated it, but it changes curvature at B and C. So if I'm looking at the F double prime graph where F double prime equals 0, that corresponds to where the x-intercept, where it crosses the x-axis. So that happens at B and C. Now, concave up, F double prime is greater than 0 before point A and after point C. And then it's concave down, F double prime is less than 0 between B and C. So less than 0 on a graph means below the x-axis. Greater than 0 is above the x-axis. So it kind of looks like that. Okay, now notice there is no like perfectness here. There's a lot of ambiguity. But one thing I will say, let's look at, for this shape, what would you say the degree of this shape is? It's kind of that W shape. It's kind of x to the 4th. Just in general, not like specifically. What's this shape? Think about what's the derivative of x to the 4th. See how this is roughly an x to the 3rd shape? And what's the derivative of x to the 3rd? This is roughly an x squared shape. So sometimes you can use your general degrees to help out with your graphs as well. Kind of find those main points. But one thing I just want to keep emphasizing, writing this stuff out, even if your graphs suck, if you're stating what you can learn from this graph about F prime and start to just kind of map it all out, even if your graph isn't quite right, mapping it all out so you're showing you understand what it's telling you is going to give you points. And every point you get is important. All right, last one. So you always have to pay attention to what graph are you looking at? This is the derivative graph. They want us to go backwards and find what does the original graph look like. So, what are some main characteristics we can decide about the graph? So the first thing I would notice, my x-intercepts of f prime of x, that's where f prime of x equals 0. That means f has 0 slopes. Where? Now notice these x, the x-axis is labeled. This is where x equals -6, x equals -1, and x equals 5. Because this is 2, 4, 6, 2, 4, 6. All right. So like I said, this would give you points that your x-intercepts from f prime tell us where f has a 0 slope. Okay. Now, in general, I know that f is increasing where f prime is greater than 0. So looking at the graph, where is the graph greater than 0? That's above the x-axis. So my intervals from -6 to -1. Where else is it increasing? F prime is positive, which from 5 to infinity. These are the places where f is increasing. Where is f decreasing? That's where f prime is less than 0. So where is f prime, the graph, less than 0? That's below. Oops, let me change the color. So f prime is less than 0 from -infinity to -6. And from -1 to 5. Now we can also, it also talks about points of inflection. So that, remember, f double prime equals 0 with our inflection points. That's the derivative of the derivative. So where f prime has 0 slopes, this is letter B and letter D, and notice it changes from positive to negative and negative to positive. So it has to also change sign. These are going to be inflection points. All right, so let's look at a graph that kind of incorporates all of this. Now, there's not a real good way to figure out our y values. So what I did is I kind of mapped out 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. It's going to be decreasing, 0 slope here, increasing, 0 slope here, decreasing, 0 slope here. That's really kind of ugly and not super accurate. But that's why I'm saying these pieces of information will get you a lot of points. Incorporating them, you might not get it perfectly on this, but go ahead and just try and get as much information as you can, and we'll go from there.